So welcome again, grade 10 students, on the day 3 of our week 1 for the 4th quarter. Yesterday, we described one of the last law being proposed by Robert Boyle, wherein he states that if the temperature is held constant, the volume of a given amount of gas is inversely proportional to its pressure. Or meaning to say, as the volume decreases, the pressure increases and vice versa. Now, to prove that there is a relationship or inversely proportional relationship between volume and pressure, we will use an equation to discuss this one. And so for today, we will solve problem on the relationship of volume and pressure at constant temperature of a gas. To start, you will need a calculator to understand our lesson. As Robert Boyle on his Boyle's law, he says that volume and pressure are inversely proportional to each other. To give us this equation, wherein V, as in victory, is the volume that is inversely proportional to the pressure with the symbol of capital P at constant temperature with the symbol of capital T and constant number of mole with the symbol of small letter n. So it is always, or volume and pressure is always inversely proportional to each other. So to indicate the proportionality constant, we will add a symbol of small letter k. Now if we will cross multiply this equation, we will come up on this one, wherein proportionality constant, or it is always constant, the relationship of volume and pressure, and they are inversely. So for Boyle's law, it is always have an inversely proportional relationship between volume and pressure. Now if there is a change happen between these two, they will always still have an inversely proportional relationship. So for Boyle's law, we will come up on this equation, wherein initial volume, or the product of initial volume and initial pressure, is always equal to the product of final volume and final pressure. Now let's use this equation to solve our problem describing or showing Boyle's law. Now to do that, let's use this procedure, the GRISA, or the GRESA. G is for the given or the given quantities on the word problem. R is the required or the unknown quantity on the problem. E is the equation or the formula to be used. S is for the solution. And A is for the answer. Take note that you should always have a unit on your answer. So now let's start. Let's use the equation and the GRISA to solve this word problem. Fryon in an air conditioning unit has a volume of 0.30 liter. It is allowed to function in a room where the pressure is about 628 mm of mercury. Assuming that the temperature is in constant state, find the final pressure of fryon when its volume is increased to 0.95 liter. So first, to use the GRISA, let's identify the G, which is the given. So on the word problem, we have the initial volume or the first volume, which is the 0.30 liter. Next one, we also have the initial pressure, which is the 628 mm of mercury. And the last one, we have the final volume. So the volume increases into 0.95 liters. Now, using this equation, let's identify the required quantity. So we have the initial volume, the initial pressure, and we also have the final volume. So among the four quantities we need to have, the one that is not identified is the final pressure. And also it is the one that is being asked on the problem. Find the final pressure. So now, to, to identify the required or the final pressure, we need to use an equation. Now, to identify or to get the equation needed, we will have this one, wherein you need to divide both sides of the equation into the the quantity beside the required quantity. So on this one, we have the required or the unknown quantity, which is the final pressure. Divide both sides of the equation into its quantity beside it, which is the final volume. So divide both sides of the equation into final volume, so then on the side of the final pressure we can cancel out the final volume, and we will leave the final pressure on one side of the equation. So the equation for this word problem is that final pressure is equals to the product of final initial volume and initial pressure divide by the final volume. So now for the solution, you only need to um, put out the quantities for each symbols. So we have the initial volume, which is 0.30 liter, multiplied by initial pressure, which is 628 millimeter of mercury, over the final volume, which is 0.95 liters. So first you have to do is to multiply to get the product of initial volume and initial pressure, and we will come up with this one. So 0.30 liter multiplied by 628 millimeter of mercury, we will have 188.4 liter millimeter of mercury over 0.95 liter. Now all you have to do is to divide these two to come up with an answer of 198.32 millimeter of mercury. So how this millimeter of mercury happens? So if you have two the same unit on your division side, you need to cancel out these two. So we need to cancel out the letters because we have two letters on this one, and we will leave the millimeter of mercury. Now let's have another example. So let's say a sample of a gas occupies a volume of 350 milliliter under a pressure of 0.75 atm or atmospheric pressure. If the temperature is held constant, what volume will the sample occupy under 1 atmospheric pressure? So to do that, we need to identify the given quantities. So first we have this 350 milliliter, and that would be our initial volume. We also have 0.75 atm, and that would be our initial pressure. And we also have this 1 atm or atmospheric pressure, and that would be our final pressure. So among the four quantities we need to have, which of them is not present on the given. And that would be the final volume. So final volume is the unknown quantity or the required. Now, to identify or to get this final volume, you need to have the equation. So again, divide both sides of the equation into the quantity beside the unknown one. So the unknown is the final volume and the quantity beside this one is the final pressure. So we need to divide both sides into final pressure. So we need to divide both sides into final pressure to cancel out final pressure on one side of the equal, and we will come up with this equation wherein final volume is equal to the product of initial pressure and initial volume over the final pressure. So now let's use that equation to identify the final volume. So all you have to do is to put the quantities on this equation. So we have 350 milliliter for the initial pressure and 0.75 atm for the initial pressure and 1 atm for the final pressure. So first you need to multiply or to get the product of initial volume and pressure. So you need to multiply 350 ml to 0.75 atm and we will get this one. So 262.5 milliliter atm if we will multiply the 350 into 0.75. Now all you have to do is to divide 262.5 into 1 atm and we will come up with 262.5 milliliter. Now how we get this milliliter? Now as I said, if you have two same unit on your division on this fraction, you need to cancel out this two and we will have or we will left one quantity and that would be the milliliter. So the answer, the final volume on this word problem is that 262.5 milliliter. Now to prove that there is a inversely proportional relationship between volume and pressure, let's have this one. So initially, on the initial state of this gas, we have volume as 350 milliliter and it changes into 262.5 milliliter. Now from 350 to 262.5, the volume is decreasing. So the quantity becomes smaller. So from 350 to 262.5, nagkaroon ng decreasing of pressure. Now, what will happen to the pressure? So from 0.75 atm into 1 atm, the pressure is increasing. So as you can see, as the volume decrease, the pressure will the pressure will increase. So that is how Boyle's law proves that volume and pressure are inversely proportional to one another. Now, for your test activity, I want you to answer the questions or the word problem on the LM or Learning Material 10 Unit 4, page 368. Use Grisa in answering. So here is the word problems on your learning material, Unit 4, page 368. Number 1. Oxygen gas inside a 1.5-liter gas tank has a pressure of 0.95 atm. Provided the temperature remains constant, how much pressure is needed to reduce its volume by one-half or by half? Number 2. A scuba diver needs a diving tank in order to provide breathing gas while he is underwater. How much pressure is needed for 6 liters of gas at 1.01 atmospheric pressure to be compressed in a 3-liter cylinder? And last number, a sample of fluorine gas occupies a volume of 500 milliliter at 760 torr. Given the temperature remain the same, calculate the pressure required to reduce its volume by one-third. Now, if there's no more questions, you can now proceed to your task activity. Thank you.